This lesson deals with supplemental problem 3.5. You can find this problem in the ECE302 ebook in the Chapter 3 Supplemental Problems on page 6. Here we have a PNP transistor with a 10-volt battery and two resistors. Could you find the current I and the voltage V if the emitter base forward bias voltage is 0.7 volts and the emitter collector saturation voltage is 0.2 volts and beta F is equal to 100? These are sort of our standard default values if we don't have any other information about the transistor. I'd like you to assume that the transistor is in the active region, and then I'd like you to check that this is true. You can find the active region model in the Chapter 3 lecture notes on page 17. Let's draw our circuit with just one ground in it. Here I've got a 390K resistor back to ground, a 2.2K back to ground, and then I have a 10-volt power supply back to ground. Between the emitter and the base, in our active region model, there's a battery whose value is 0.7 volts. So I'm going to draw that in over here. And the current I sub B is the current coming out of the base. Then between the emitter and the collector, there's a current-controlled current source of beta F times I sub B. And the voltage across the emitter collector is just the difference of these two node voltages. Now I need to analyze the problem and show that I sub B is greater than or equal to 0, and that the emitter collector voltage is greater than or equal to V sub EC sat. Let's find the current in this resistor. It's going to be the voltage across this resistor. So just go around the loop. The rise in voltage then would equal the drops of minus 0.7 and plus 10. Divide that by 390K and you get the current coming out of the base, which is 23.8 microamps. We're going to multiply that by 100, which is 2.38 milliamps. And now I'm going to solve for the voltage across here. This node voltage is 10 volts. And then this node voltage is just the current times the resistance. But the current in here is the collector current, which is 100 times I sub B, which we found to be 2.38 milliamps. 2.38 milliamps times the resistor of 2.2K, subtracted from 10 volts is 4.764. Since this is greater than or equal to 0, that checks. And because this is greater than or equal to 0.2 volts, that checks. Now that we verified the transistor model, we can now solve for whatever quantities we were asked for. Current I is the same as the collector current, which is 2.38 milliamps, and the voltage here is just going to be that current times 2.2K. 2.38 milliamps times 2.2K is 5.236 volts. And this is supplemental problem 3.5.